back up again. So that is what they call the 0 point of the antenna. Even though you have 300,000 watts of power in the wires, that has nothing right there. And what that does is it balances it. It's a beautiful, balanced, efficient antenna. That is what the engineer has to work on. He was able to tune it for 9275, but the higher frequency, that stub line has to be just moved a little bit and adjusted. And that's what the equipment came in. He's supposed to be here the first week of November, he thought. So the one that I repaired is on the south side on that left, where it hits the dipole. The dipole is, let's go back to what a dipole is. Dipole is two poles. You have two diamonds, left and right, and then two diamonds left and right on the top. So it's a double dipole. The feed line comes in and feeds both of those exactly balanced. The left, and right have to be exactly to the centimeter the same length. So it's totally balanced. But where that feed line hits, right underneath that insulator, on the vertical, there are 7 strands of wire in the conductors. It's aluminum. And underneath that, it worked it and cracked some of it. So then when we were transmitting last week, it burnt that last one off. So then what I had to do is go up there with the lift and then take aluminum conductor, wrap it around 7 times. And then so the repair is about that tall, but it brought it right back into tolerance again. We were at 1.48 standing wave ratio. When you're transmitting, theoretically, you want all your power to go out, but realistically it can't, because there's too many variables. It can be moisture in the air or whatever. So it's called reflected power. It's what the antenna is feeding back into the set, and we run about 1.48. That's what we are right now. Yeah, so it's aluminum, grade 5 or something. I don't have it. I try to clean up when I'm done, but I have some in there. So when he comes back in November, what he'll do is he's going to disconnect the antenna. He's going to balance the feed line. The feed line is all different. I mean, that's Amazon design. So we don't know. He thinks that's where the difference is, where he has to balance that feed line and then balance the antenna and then put them back together again for 15 minutes. Then we'll be able to make them go. But if you want to look at some of those connections, it's really incredible. Air is the best insulator. Yeah, you can use a weight to have it balanced rather than bringing it to the ground. If you bring it to the ground, then you have to have all your insulators.
I used to do 2 wires running
the 2 dipoles.
To there, yeah.
It's 1 meter between each of the insulators. It's because you have to break that up. You can't start traveling.
It's this right here, yeah.
It's like the one that's holding
Just 4 seconds.
That specific place. Now the concept of a curtain array dipole antenna is that your RF comes off the transmitter into your antenna and it takes off. But if you think about it, it takes off in every direction. Denise says, I don't know about those. I have at specific times I have alarms go off, so if I'm overworking, I can log in and make sure it's doing what it's supposed to. So then what the curtain is in the back is each one of those conductors, the horizontals and verticals, are specifically spaced for this antenna. So when you apply RF to the antenna, RF is different than electricity. RF goes on the surface of the conductor. It doesn't go in the conductor. Like those high power wires where your electricity, you're pushing the electrons off through it. RF travels on the surface. So as soon as that antenna becomes live, the spacing is so critical in that curtain that the RF will go around those conductors in about a pattern like that, and it becomes a solid grid of RF, standing RF. What that does then is nothing can go backwards. It's reflected.
Reflected back there.
Now when we do an RF test and you walk out to the gate, your RF meter drops down. You go out to the end of the apex, RF drops right down. It takes off that fast. We have about a 38-mile takeoff ramp where you go 38 miles down the road and you can't even hear it. And Sister Johnson was in the hospital. I took the radio down, and she was so disappointed because here, she couldn't hear it. But I logged in and let me listen on there.
Thank you.
No problem. It used to really affect the old transmitter because it wasn't automatically tuned. Last week was the end of Ian, the hurricane that came up. We got, in the afternoon while we were transmitting, we got some pretty good stiff winds. You'll see, I'll show you when we get in there on the screen again, the position of all the motors, and it sits there because they turn yellow. It sits there and they compensate for itself.
Here's Glenn.
Because
That's my husband. Yeah, there's Tabby. But that's what she's young.
It changes the impedance of the antenna, so the transmitter automatically compensates for it. The old one, you just have to take it off the air, or go to something.
When the adjustment takes place, when the adjustment between 15
right, and that's a nice thing about this is it's very well. If something goes wrong, you can research it. You can look it up.
hey, when 15, you have to display,
15, 150.
and they have to balance it between the two, will that affect reception in America?
It won't. No, the antenna will be doing the exact same thing. Yeah, it'll be exactly the change will be in the antenna, but then it will be. Remember, I talked about that 0 point. That 0 point just has to be moved. He was getting about a 3.7 reflected, and at 3.0 you don't want to. It starts stressing the transmitter. You start stressing because too much is coming back into the set. Yeah, he said you could turn it down, turn your power down real low, but he said it just stresses everything. Exactly. So he just has to bring that up to 0, and then it should be good to go. Now we have a problem right now getting terminal posts for our fence. We could get the fencing, we could get the horizontal clamps, but the big terminal posts for the corners and the runs, can't get them. They were a month out, and it's over $1,000 for just those 8 posts. So we're looking for a cheaper source, but right now we just have caution tape up. But what we do is when we're transmitting, everything is locked. We shut the gates, everything. And if you're stupid enough to crawl up there, cut those off. And we have to make a beautiful sign. That's true. You can do it. We won't do it again. Now another thing you want to notice, you see those round like flower beds at all 4 corners of the building? This we utilize for grounding system. They worked on that and perfected it in World War II over in Northern Africa. What it is you have rebar, 1/2-inch rebar that's in a grid shape, starting in the foundation, coming up, and then gridded in the floor itself. I don't know if you notice those little pockets around the floor of the transmitter. Everything's yours too. That's all tied to that. Now that whole grid comes outside of the building, 24 inches, and then it connects to a 2-inch copper pipe. It's all welded to all the rebar is welded to that copper pipe. I'm trying to think of the name of the weld system, but it's a clamp weld, and then you light it and it melts over. Yes, yeah, it's like that, yeah. And then, so then that goes all around the perimeter, tying the whole grounding system together. And then on the ends of that, on the 4 ends, then we have flat. You see see some of the flat copper there? That comes up, that's welded onto that. It comes out and it's split 3 times with 3 10-foot grounding points. So, and then you have to maintain that. You have to take those apart and clean them once a year. They figure once a year. That's why they're protected. So we had to say, now we got to get them protected. So that's what you see in the contract. They don't really like a steel building to have a transmitter in. But in the contract, it actually says that if being put in a steel building and you do not earth it correctly, the building will melt. It says it right in the contract. So it's our responsibility. They're saying we have to make sure. Yeah, they really will melt. Yeah, concrete block. Filled concrete blocks. Yeah. Another thing you want to notice is we built the office and didn't really think about it until we got on the air. An amazing amount of RF is in that building when you're transmitting. Now, when we start when the transmitter comes on, if anybody has a pacemaker or something, make sure you go outside. Make sure you go outside the gate because the RF is just it is. It won't hurt a normal person, but when you're here working, it messes up cell phones and everything like that. So you'll notice the wire on the corners of the door is a grid wire. The whole office has 2 layers, floor, ceiling, walls, even in the outlets. So that does the same thing as that. What it does is the RF energizes it and it blocks it, creates a wall. It's called a Faraday cage. You can allow all that electricity and RF around you, but it won't penetrate it. It's very, very light. And it was funny because we did the walls and ceiling and it was still off the charts. And I said, is it coming up through the corner? Well, you'll notice all those deals, the doors are steel and they're all grounded wood. And I told John, the only place could be the floor. It's got to be coming up right over the concrete and in, and we put it on the floor. That communicates with the office. Networking. Yeah, we actually don't use that one anymore. We went with a cell because it's in front of the antenna. We put that up when Deacon Nathaniel was here, and it worked. It was nice. You could grab and drop files and things like that. I live on the clock. Everything's about the clock. Because he has the sensor tied on the backside, you know. Tied on the backside, when there's cloud vision, we need to tie it with the tower. I think that's in the solar detector. They still stay away.
I had that experience with the cabin. So I could get
Yeah, these have reflective eyes. I think that's one of the reasons. But you will notice the owl on the top tower and the south tower is gone. It blew off in the wind. And we do have about 10 up there on the top, but they don't come over here. Okay, let's go see how it's doing. But you can see the